So how this random access procedure is done? Mobiles, as part of the special sync signals, they would be transmitting something called as preambles. That is a technical name for it, because typically preamble is a word that we use to convey the meaning of first thing. Anything that goes first is typically called as preamble. If it goes last, we can call it as postamble in that terminology. Because it's the first thing that normally network mobile transmits to the network, they decided to call it technically as preamble. These preambles are specially generated, uh, symbols or Jadavcho sequences. These preambles. The advantage of the preambles is if they are transmitting two different preambles at the same time, uh, like they won't collide with each other. That is the advantage. That means that Genome B, even if two different Jadavcho sequences got transmitted exactly at the same time and by you in the same resource, same physical resource, Genome B definitely would be able to identify that there are two different preambles present in it, or two different scrambling sequences present in it. And how that is possible? These Jadavcho sequences are generated with orthogonality. So there is orthogonality between them. So when they get merged also, from the mixed signal, the Genome B can identify what is the Jadavcho symbols that are transmitted, or what are the Jadavcho sequences that are transmitted. So that's kind of possible. Even if all of them are traveling by using the same resource. But when the collisions will occur then? Now, whenever a collision is occurring, such a situation is what we are going to call as contention-based random access procedure, where UE is allowed to randomly select a preamble that it wants to transmit from a available list of preambles, from a provided list of preambles. When mobile transmits such a preamble, there is also a possibility that some other mobile wanted to transmit the same preamble that you are transmitting. Why the other mobile is also transmitting the same preamble which you are transmitting? Because mobiles are not coordinating with each other. You are transmitting your preamble, the other mobile is transmitting, the other mobiles pick the preamble, which we call it as a random preamble, because you randomly pick up one preamble out of a list of preambles that are available. Typically the number of preambles that are available are 64, numbered from 0 to 63. So you pick up one number, your other mobile equipment which is transmitting the preamble at the same time would pick up another number, with possibly other number. If luckily the other guy picked up other number, that's good for you. If both of you are transmitting two different preambles, there is no collision. But if you are picking up a preamble, the same preamble is picked up by the other mobile as well, unluckily, then that leads to collision or contention in this case. Both English word meaning is the same, which is typically represent some kind of an collision going on between these two subscribers who decided to transmit the preamble exactly at the same time, that to the same one. Now, when this kind of a contention or a collision occurs, UE and Genode B have to further work out to resolve the situation, to resolve this collision. Now, you cannot control this in the network. Two mobile phones may want to get the resources at the same time from the Genode B, decided to send the preamble at the same time to get the resources. Because this random access procedure can famously be used for this resource acquisition as well, to acquire the resources. So two mobiles needed the uplink resources at the same time. So they decided to send the preamble at the same time. But If they are picking up two different preambles, good. But one preamble, problem, contention. But the second criteria is called as contention-free random access procedure, in which network will suggest the preamble that the UE should use in a prior step. Network will come to the mobile and tell that, hey, what you are going to transmit so and so preamble. Obviously, that preamble that the mobile is asked to use is definitely no other subscriber is allowed to use that preamble because it should not be from a common list. Basically, from the available preambles, network will separate out some preambles and segregate them and keep it with in its ownership. And whenever it would like to give this preamble to a subscriber based on a special need, it would be provided to the user. Hey, so and so preamble, I am allocating it to you. You are allowed to use this preamble to perform your random access procedure. Please use it. So when such kind of activity happens, now there is no possibility for the collision, no possibility for the contention. Reason, as this is exclusively the preamble is provided to you, no others will pick up that preamble number that you are using. So when you are transmitting a preamble, even if somebody else transmitting a preamble, it is damn sure and definitely guaranteed that the other mobile would is definitely would have picked up some other preamble which you are not using, which we other than the one that you are using. Now, when there is a possibility for collision, such a procedure is called as contention-based procedure. When there is a possibility for collision, when there is no possibility for collision, we consider that as contention-free random access procedure. That's the difference between them. Now, in contention-based random access procedure, steps would be more because first you wanted to confirm whether the contention or collision occurred or not. If occurred, how to resolve it. If not occurred, consider that procedure as successful. So obviously, it would have more steps compared to this contention-free random access procedure. Now, this kind of a contention or a collision is the possibility of only this particular channel called as PRATCH, because this is the only channel that mobiles are allowed to use on their own wish whenever they want, without any specific allocation. Rest of the channels that the mobiles you should use in either downlink or uplink must be done on the allocation basis. Only once it is allocated to you, you should use it. That's it. Simple. So no collision possibility. That's why we are discussing this only for this channel, this contention-based, contention-free mechanisms. So what are the steps involved in contention-based procedure and contention-free random access procedure? Shortcut, we call it as CFRA, CBRA, contention-based, contention-free random access procedures. So these are the total steps involved. But again, in contention based, we have two types. Contention free, we have two types. Type 1, type 2. So again, steps are different in type 1, type 2. First, we see type 1, contention based procedures. The first one, left hand side top. First, GNodeB sends the system information to the mobile, in which GNodeB will communicate to the mobile which preambles out of the 64 preambles are allowed to be used by the UE for its contention-based operation out of the 64. For example, GNodeB can segregate and say, hey, I'm allocating you like some 56 preambles. Remaining 8 you leave out. Remaining 8 I am keeping it for myself for the purpose of providing it to subscribers for contention free guys. I will use them. So you have to pick up a preamble from these first 56 preambles only, 0 to 55. And in this system information, the details would be provided by GNodeB, various details like exactly where you can transmit your preamble, where are your PRATCH resources to transmit the preamble, etc. The kind of complete details would be provided. What kind of a preamble you have to transmit? There are several types of preambles also are there, which we'll study. So what kind of preamble you have to transmit? All that will be provided in this system information. So that means mobile, in order to perform the random access procedure, must read system information first. It is crucial because it contains the crucial information in it to perform this thing. Okay, now mobile received system information already, so it can perform random access procedure. The further steps are called as random access procedure. So the system information is not called as a step of random access procedure. It is happening something prior to this operation. It is a prior step. Random access procedure is only these 4 steps. Now, when does mobile starts this random access procedure? If mobile wanted to communicate with the network, GNode B wanted to say something to the GNode B, or you wanted to request for a radio connection, or you wanted to request for something from GNode B, then you have to achieve the uplink sync. When you have to achieve the uplink sync, you have to start the random access procedure. So that means some event occurred, which kind of, you know, uh, which kind of made the UE start this random access procedure, and it is starting it by transmitting this preamble on a PRAT channel. Because this is the first thing that is happening in this particular procedure, we call it as message 1, this preamble transmission. So this preamble is the special Jadov-Chow sequence signal that is getting transmitted on PRAT resources. We call it as message 1. And when GNode B successfully receives this preamble, or if once it receives the preamble on the PRAT channel, which it is continuously listening to, it would send a reply back to UE. Hey, I'm giving you a random access response, which is considered as message 2. I have received your preamble. I'm responding back to you. So this random access response would come back to the mobile equipment on the PDSCH channel. So in this random access response that is arriving from GNode B to UE, there will be timing advance information that mobile need to apply for uplink, because GNode B might have estimated this preamble delay. On the basis of the delay estimations, GNode B would kind of send timing advance related details in this random access response. Then only mobile can achieve this required timing adjustment or uplink sync it can achieve. And this random access response also contains details like what are the uplink resources allocated to the UE so that it can communicate back to GNode B and send a big message on PUSH. You are not allowed to use PUSH directly. You are allowed to use PUSH only once your resources are allocated for you on PUSH. That PUSH resource information is conveyed on this random access response. So by using that resources, by applying the exact timing adjustment that is requested by the GNode B, by using all those characteristics, UE is allowed to transmit the message 3 in this order, which is some kind of a request it is sending to the network, demanding network for something. Hey, I want a connection, I want that, I want this. You can request for the things. So whatever the request you are sending to network is called as message 3. Actually, this message 3 is what might have made mobile equipment to first of all start this random access procedure. Mobile may be quietly taking rest in his idle mode, taking rest and not doing any activity at all. But suddenly this there is a message requirement for mobile equipment to report to the UE to the GNode B. So immediately it detected that, hey, if I have to send this message through to the network, I need resources in uplink PUSH. So definitely, what do I need to do? I need to like kind of um, you know start this random access procedure for performing that activity. So is this message 3 must be most of the times the reason for starting this procedure. What will be different things in message 3, etc. We will study it in the higher layers, because typically this message 3 would be arriving from the higher layer. And that is what would cause the UE We use lower layers to start this random access procedure. Okay. Once mobile successfully transmits message 3 by using the PUSH resources that are allocated on this random access response message that is you are getting back, then mobile would have to wait for an acknowledgement for making sure that this message 3 is not corrupted, because the procedure you are using is contention based. There is no guarantee that the message 3 that you are transmitting would be successfully received by Gnode B. There is a possibility of contention or a collision. In what cases it will occur, why it will occur, I will explain. It's a complex mechanism. We have to unwrap it step by step. But for some reason, this message 3 could be corrupted. In what cases, we will see. But in order to detect whether it is really corrupted or not, you have to wait for the Gnode B's confirmation. It will be coming in the form of something called as CRI, Contention Resolution Identity, which is sent to the mobile on PDSCH channel, Physical Downlink Shared Channel. For sending uplink message, you are using PUSCH, Physical Uplink Shared Channel. For receiving anything, you are using PDSCH. In this, you would receive CRI. Now, what is the CRI? The CRI is nothing but normally a small part of this message 3 itself. For example, if the message 3 is 6 bytes, the CRI would be exactly equal to this message 3. The same, whatever message 3 you have transmitted to Gnode B, that itself would be coming to the mobile equipment back as CRI, in the form of CRI. The same message 3 would be coming. UE kind of will verify, hey, the message 3 that I have transmitted is equal to the CRI that I have received. They must be actually same. If they are same, UE kind of can come to a conclusion that, okay, my message 3 is successfully transmitted without any collision. How can I say? Because my message 3 that I have transmitted is matching with the CRI I have received. If it is matching, good to go. So that means that this contention based random access procedure, even though it is having a possibility for collisions, collision did not occur. Your procedure is kind of considered as successful. It happened. Okay. So this is contention based random access procedure where we have involved 4-step mechanism. Now we are going to study the same contention based random access procedure 2-step. What would be the difference here in this? In 4-step random access procedure, in system information, you will have information given related to only PRACH resources. That's it. That means by using which PRACH resources you can transmit the preamble. PRACH is an uplink channel that mobile can use to send the sync signal or preamble. Only preamble where you can send that related resources or information only would be sent in system information in type 1. In type 2, what do they do is in system information, the network advertises the UE, the PRACH and PRACH resources, as well as at the same time PUSCH resources. Both together would be allocated to the UE. That means that some amount of PUSCH resources are segregated for this random access procedure related operations. It won't be allocated to subscriber for general purposes or for data transfer purposes. Indeed, these PUSCH resources are reserved only for these random access purposes. And that information is conveyed to the mobile when mobile is reading this system information when it is coming up. Now, what is the advantage in this second case? Mobile is allowed to do first step and the third step together at a time. So it will transmit the preamble by using PRACH resources. It would transmit message 3 uh, by using PUSCH resources that are provided. Okay, now, if this is cleanly received, you get a rare random access response containing your timing adjustment related details and further uplink resources that are required for your further continuation of operation. And then you will receive the CRI in this case. But again, you do the comparison and everything is absolutely the same. There is no change in it. Whatever the message tree that you have transmitted, you are just naming it differently now. The preamble plus message tree together, we are calling it as message A in this, just a technical name. Whatever the reply that you are receiving, that is what is named as message B in this two-step random access procedure. But ultimately, what you have to do is whatever the message tree you have transmitted, the higher layer message for which you have started the actual procedure, you started this operation, you kind of have to verify that. Once the verification is successful, you will consider this random access procedure as successful, the two-step random access procedure. You conclude that this contention-based random access procedure is good to go. It's working. This is contention-based. But in contention-free, what happens? CF random access procedure on the right-hand side part. Now, in this system information, you will get to know about the PRACH resources normally when you are in idle mode, when you are downloading the system information. But in order to mobile equipment, in order for the mobile equipment to do this CFR procedure or CFRA procedure, contention-free random access procedure, mobile must have been already in connected state earlier. So when the mobile was in connected state earlier as part of some other operation, network would have provided you this RRC configuration in which network would have told you what is the special preamble that you are allowed to use. It will provide the details, special preamble details it will provide you. And what is the other purpose? Why mobile was connected earlier and why mobile wanted to do the random access procedure now if it is already in connected state? As I told you, random access procedure is needed whenever you need uplink synchronization. And uplink synchronization is not continuous. You have to do it. You normally would be losing it every now and then continuously. You have to continuously keep doing uplink sync whenever it is required for you. As it is not a continuous transmission, as I explained you that in the previous slides. So the special preamble details are provided to the mobile during RRC connection, earlier RRC connection. For some reason, it is provided. Why it is used, we will learn that later. This random access procedure will keep popping in for the entire duration of our course. It is one of the complex procedures and involved in many layers. So we'll have to study gradually, phase by phase. Okay. Because you have the special preamble available, which is not allocated for anybody. So mobile now can use that special preamble and transmit its message one on PRAC channel. Now there is no possibility for collision as you are transmitting a special one. Now you get message two, random access response, where in which you get the timing advance values, etc. in it, and what are the resources that are allocated for you for your uplink operation and so on. Various details would be there in it. You get those details. By using that uplink resources and applying the timing advance, mobile would be able to transmit message three. The message that is indeed might have started this entire procedure altogether. You transmit that message three, but in this particular procedure, you don't have to wait for the acknowledgement. Now there is a guarantee that this message three would have been transmitted on the PUSCH without any collision worries. As you have used a special preamble, it wouldn't have been collided with any other preamble. There is no possibility for even message three collision also. So last step, which we consider normally as message 4 in the random access procedures, is absent in this case. If you call, simply you are calling them with message 1, 2, 3, 4 in that order. Message 4 is absent in contention free because you're damn sure that collision wouldn't have occurred as you are using a special preamble allocated to you. So you don't have to wait for basically you don't have to worry further acknowledgement from the other side, from the GNOD being. So same way in type 2 contention free random access procedure, which you are performing in two-step way, first, system information is kind of mandatory for every mobile, but again, special RRC configuration is required because network need to tell you what is the special preamble that you have to use. It will provide that special preamble. So mobile will use that special preamble and transmit message A along with the PUSH resources that are allocated for your operation. Because this is a two-step random access procedure, as part of the system information, you not only would be given about information about which PRACH resources you can use, but you are also given information related to which PUSH resources you can use, because you are sending here combinedly. So this is little faster. Type 2 procedure is little faster compared to type 1. But it is going to basically waste some PUSH resources as they are reserved for random access mechanisms. In type 1, network GNODB need to allocate the PUSH resources to a subscriber only when the subscriber sent their preambles. But in the second case, type 2, network need to reserve some PUSH resources for this random access procedure and provide that information in the system information itself, like kind of permanently. That means you are altogether reserving the resources for PUSH in on the PUSH space for this operation. So if no mobiles are doing random access procedure in the cell, you are kind of wasting those PUSH resources that are there. You're wasting them because they are already reserved for that particular purpose. You are not using it for the data transfer purposes of the users. Now, in this case, you don't care about, again, the third step, as you can see, once you transmit the message to A, you will receive the RAR, which is, we consider it as message B, but you are not worried about CRI in that. Only you are receiving just RAR. That's it, random access response, which gives you the timing advance value that the network is sending you. Okay, now, we cannot understand all these procedures at once. Now, what we are going to do is we are going to expand one procedure to a lot deeper level steps. This type 1 part we are going to expand. So first we are studying contention based random access procedure. This 4-step one, by considering that the system information is already available for the mobile, where mobile knows which preamble it will have to use, special preamble it will have to use, and in which PRACH resources it will have to transmit that. Everything is known to the mobile. We are going to consider that in UIT and learn this. Okay. And remember, this random access procedure on the mobile and GNODB side involves two protocol layers, MAC and physical layer. Actually, we are supposed to study only physical layer. We are right now studying physical layer. But when it comes to this RAR, even MAC layer, layer 2 is also involved. So it's a 2-layer involved procedure. Each layer has got a particular job to do. Now, on the left-hand side, you see box, which is UE. Right-hand side, you see the box, which is GNODB. But in that, if you see the color segregation, the one color, which is MAC layer present in the mobile, physical layer present in the mobile, and both are involved. So even on the GNODB side, both layers are involved, the physical and MAC for this operation. Okay, so what kind of triggers this random access procedure? The MAC layer, first it gets a notification from the higher layer. So if you see the left-hand side of the MAC layer, you can say that it is RLC. Kind of, it is RLC is the one that is talking to Mac and notifying something. Hey, I have a message. Let us call it as message three. I wanted to send it out. RLC demanded Mac layer. Which Mac layer? US Mac layer. This can be a connection request message that mobile want to send to the network to request for the radio connection. RRC prepared this message. RRC gave it to RLC. RLC is kind of telling this to Mac layer. Hey, can you please take this message tree and send it out? When RRC decided to request for a radio connection, and just now we are coming up. Can we please do it? Now Mac cannot allocate the resources on its own. In order to allocate the uplink resources, it need to go and communicate with the GNode B. That's kind of needed. Now it starts the random access procedure because it need to get uplink resources. It also need to get the uplink synchronization because it don't know where exactly need to transmit in uplink slot positions or your symbol positions. You have to accurately adjust yourself the transmission. You have to do timing advance. We discussed about that. So it wanted to know the timing advance related details. So started the random access procedure, MAC layer. RAP is a shortcut for that random access procedure. So as part of it, what is the first thing MAC layer would do? Already mobile would have read system information earlier to this, and mobile would know out of the total available preamble numbers from 0 to 63, how many preamble numbers are available for your operation. That is the things that Mac layer already known about. Because after receiving the system information, RRC configures those details into the Mac layer. I told you RRC is the one who configures all the lower layers. So after receiving the system information, RRC would have told the Mac layer, hey, how many preambles are available for our contention-based operation, 4-step random access procedure operation. It kind of told you about that already. So what does the Mac layer do here? It will randomly pick up one preamble. So the preamble it is picking up here, any number from 0 to 63, it is just a number. If you take that number, it is 6 bits of information. 0 to 63, 2 power 6 minus 1. It's a 6 bits of data. How do you normally pick up anything randomly? You throw all those numbers into a software dabba, and you kind of uh, mix well, and you have to take out one chit out of it. So that's what is random is. You have to pick that up randomly. So it will randomly pick up one preamble and convey that information to physical layer. Tell the physical layer that, hey, by using the PRACH resources, can you please transmit the PRACH special signature by using this particular the preamble number I am suggesting, the corresponding signature you have to transmit in the air. Mac layer is demanding the physical layer to do this task. Physical layer would have to allow that, would have to accept it, that request from the Mac, and would do this. So it sends on this PRAC channel, by using the resources that are already indicated on system information, it transmits this special Jadov-Chos sequence or preamble. It transmits. So what is this Jadov-Chos sequence? What is there in this preamble? Now the preamble story starts. So the preamble that is selected is 0 to 63. The preamble that is generated is by using this, this is the preamble symbol. E to the power of minus j pi u into I plus 1 by LRA. Now, if you remember our modulation class, anything that is represented in e to the power of I theta with r is typically considered as 1. In this case, r is not there. So in front of it, we can consider as 1. So r is gone. So you can write it as cos theta plus I sin theta in simple terms. So now this whole thing, including this minus and everything, this becomes your angle. This whole thing is your theta. But because it's a sequence of values of size, how much? LRA. What is the size here? LRA. This is configurable 839 or 139 or 1151 or 571. So this size would be indicated to the mobile equipment as part of the system information. Like what is the preamble sequence size? Like how many samples you have to generate in the e to the power thing? How many symbols you are generating? Each, if for example, if network told you 839, you have to generate 839 symbols here by substituting in this LRA, you will substitute 839 and I also becomes 0 to LRA minus 1. LRA is 839 minus 1, 838. So that means you are generating 839 symbols to place on 839 symbols to place on 839 subcarriers. So that means if you are generating these 839 symbols, you must have 839 subcarriers reserved for transmitting your PRACH. But what goes into this equation? What details are present inside this equation? Let us try to look into it a little bit. Pi is constant, fixed, which is 180 degrees. This U value is going to be separate for each cell. This U value is going to be kind of provided to the mobile as part of the system information. So how does mobile know what is the U value that it should use while generating these symbols, so these 839 symbols for the special Jadavcho sequence? How that is provided? That is provided in this I this index value here I. This I value, for example, I have put the case example for 830 thing is 839 scenario. The I value can be anything from 0 to 837. One of these value would be suggested to the mobile as part of system information for you. For example, the suggested value is, let us suppose that is the 399, assume it is suggested. So I value is suggested as 399. In this I here is different, guys. This is index. This I is and that previous I are not same. Forget about I here. Let us call it as some Z, or let us call this as some T. Some T is equal to 399. This value is provided. Then how does mobile know what is the U value? So there is U value. This for 399, the value that is applicable is 794 in this last value. For 380, the value applicable is 11. For 399, the U value applicable is 74, 374, the last element in that row. So 380 to 399, you will have 19 numbers or 20 numbers, including both. So this is applicable if you get, this number is applicable if you get value 381, 382, 383, 384. For each number, there is, for each index value here, there is this number. So you get the index. From that index, you will find out this table is known to every 5G mobile phone in the world. So this table is known. So from the received value in the system information, you can identify the U value. But I am telling you, U value is different for different cells. That means in every cell, the generated preamble sequence would be different. That is the first point. Second, this I value, I into I plus 1, is changing based on the symbol that you are calculating. Because you have to, how many symbols you have to generate if the LRA size is 839, you have to generate 839 symbols. So first time symbol number will be 0. So you substitute 0 into 0 plus 1 by LRA. When you substitute 0, everything becomes 0. E power 0 is 1. The first symbol is always going to be 1 plus 0j. There is nothing else. But the second symbol onwards, it will be different. I value you have to substitute in the second time is 1. 1 into 1 plus 1. by LRA is 839. You get there. That will give you one theta, one angle. But the speciality of these symbols is their angles all will be different. They are all angular modulated symbols. All these Jadavcho symbols are angular modulated ones. But all their radius is one, R is one, because there is no R in front of it. So that means that their R is always one, but their angle would be different. So in the spectrum, these 839 symbols would be having 839 different angles, circularly changing, because we are always taking this product and dividing that with LRA, which is 839. Every time you divide a number with 839, you will get different angle. So you will have 839 different angles you will be having throughout your band. So these symbols that you are generating are not QPSK symbols, are not 16 QAM symbols, etc. These are specially modulated symbols. You can say that circular modulated symbols. We are calling it a circle because you can place all the symbols on a circle because their radius is the same, R is the same for each one of them. Only theta angle is different, spread through the full band, full quadrature. Now, it could be 139, it could be 1151, or it could be 571, depending on different cases. Preamble format. How the preamble format is decided, what is in the preamble format, again, I'll have to show you that. But before I go to that, I'll explain the rest of the part first. Now, this preamble would be cyclic shifted by the CV value, these preamble symbols. For example, we take 839 as example. So we have 839 symbols available. These will be cyclic shifted by the CV, these 839 symbols. What is the meaning of cyclic shifted? You can consider it as rotated. A rotation takes place on the basis of CV. Why do we rotate them? The CV value would be dependent on various factors, like the preamble number that you have picked up. Let us suppose you can pick up from preamble number 0 to 63 any number. If you have picked up the preamble number 0, let us suppose that if the CV is completely dependent on this preamble number itself, now there is no rotation. The 839 symbols would be placed onto the subcarriers, 839 subcarriers as it is. You would place them. So there is no rotation that required to be done. But if you pick up a preamble number 1, then these 839 symbols would be rotated by 1 unit. That means the first symbol will become the 0th symbol, and 0th symbol will become 839th symbol. The rotation took place. So if you have the symbols, the first one will become 0th, second one will become first, third one will become second. Like that, you will have up to 839. 839 will be used as last but one. 0 will go to the last unit. 1 unit of cyclic shift took place for these symbols. Like that, depending on the preamble number that you have decided, the corresponding cyclic shift takes place here for these symbols. Now, what is the idea? If two mobile phones are transmitting, your mobile transmitting the preamble symbols, some other mobile transmitting the preamble symbols, each of them will pick up a different preamble number. So each of their, even though the 839 symbols they will generate are the same, but their shifting will be different. Their preamble shifting will be different. So you are transmitting the same 839 symbols by shifting by something. The other mobile also transmitting the same 839 symbols by shifting by some other units, because both of you are picking up two different preambles randomly. So the cyclic rotation is different for both of you. So the mathematical logic, how it works out is, when both of you transmitted two different preambles together, their energy will become doubled, or their energy would be crossed at times. The symbol's energy would be crossed, or would become together one, or they will be acting against each other. So what ENODB would be receiving is kind of a mixed thing from it. But ENODB can estimate, hey, in this mixed thing, which preambles are present. For example, if you do the 0 shifted signal and 5 shifted signal, the output signal is different. From this output signal, the G-node can easily estimate that this signal can be only formed if 0 and 5 got merged. So that means that the two mobiles who have transmitted the preambles definitely would have transmitted 0 and 5. 0 is shifting and 5 shifting. Only with that, I get this unique combination values that I'm receiving. We can estimate from that kind of special thing. So if in the received signal, if 0 and 6 are present together, or 0 and 5 are present together, and 13 and 29 are present together, what combinations, what shifts together formed the received signal, we can estimate that. That is the speciality of these Jadavcho sequences. That is why you are performing the shift, depending on your preamble number picked up. Okay, now, but one important point I have to tell you is this CV is not purely dependent on you only, it is not dependent on the preamble number you are picking up. It will have other factors to it as well, this CV. What are the other factors that are associated to CV? Now the cells in 5G or 4G or wherever, the cells would be identified as medium speed cells and high speed cells. They are identified as, or low speed cells. For example, in a cell where there is a highway present, can be considered as a high speed cell. Um, the cells where there is no highway, which is like, for example, urban city area in a very dense colony, it may not be having highways to make the devices travel at 100 kilometers per hour, etc. So depending on the cell's conditions, they will decide some parameters and provide that to the mobile. So mobiles will have to shift these, these particular preamble symbols on the basis of those provided parameters. So for every cell, the shifting would not be equal. The shifting would be different. So for high-speed cell, the shifting would be completely changing on the basis of high-speed conditions. Because in high speed, mobiles would be traveling at high speed. When if you take mobiles traveling at high speed, when it is going closer to the cell center, it kind of sending the symbols, it would be sending the carrier wave much faster rate. Because if you understand the Doppler effect in your from the science, in Doppler effect, what happens when an ambulance is coming towards you, the sound kind of increases at rapid pace. When the ambulance is going far away from leaving you and going away, it would be dropping, the sound would be dropping at much higher rate. That is because of something called as Doppler effect. The Doppler effect won't not only be there on the sound, it will be there on your the radio signal that is transmitted from the mobile as well. As it is very fast approaching the G-node tower area on a high-speed traveling path, when it is transmitting the you know uh, the symbols converted into samples, the samples would be very tightly packed. They would keep coming at the G-node um, at fast rate when you are coming near to the tower. But when you are going away from the cell tower location, then they will be their sampling distance will become higher. So in order to adjust those situations, and still you will be able to receive this preamble even when for the mobile devices which are traveling at high speed. So they made some special arrangements for that. These are called as correlation zones, which I won't go deeper into it. That much concept is enough for you at this stage. Okay. Now what happens? So the CV value is not purely dependent on the number, but we are right now, let us consider it as purely dependent on the number. That much shifting takes place. And the shifted symbols, whatever you have to now start transmitting them. While transmitting, what you are going to do? While transmitting them, you will have to use first DFT mechanism. So it is kind of mandatory for doing the, um, you know, generating DFT symbols for these 839 symbols. If you remember, transform precoding. So you have to perform transform precoding because it is uplink operation. So you're performing uplink operation here for converting these converting these symbols that you have generated 839 of them, you convert it into frequency domain by applying the DFT mechanism. So you take each symbol that is cyclic shifted already. You're not taking this one. The cyclic shifted one you are taking, and you are performing a DFT operation. So this is DFT to convert the symbols into frequency domain. At the end of it, what is the size of it? Still n 839 only to carry it on 839 subcarriers. If if the size that is considered is 839. And what do you do to these 839 symbols? Now each of the symbol you have to convert it into some number of samples by placing them onto subcarrier position. Because when you are transmitting, you will convert it into samples, and the samples you place onto the carrier wave. That is what you do. That's what we have learned in the entire modulation concept. So what you're going to perform, these 839 symbols, each one of them, you will be ranging it from K0 to LRA minus 1. LRA is 839. So it would be running from 0 to 838. So this summation operation runs for 839 times. Every single time you take one symbol, one DFT symbol that you have already decided. So this is the DFT symbol. You're taking the DFT symbol and you are converting it into T number of time domain samples by applying this delta F RA as your frequency component. It is not called as delta F, unlike our normal operations. Why it is called as delta F RA? Reason is we use special subcarrier frequency for random access procedures. It is much little, normally it is lesser than our operating subcarrier spacing. Normally, if our operating subcarrier spacing is 30 kilohertz, we would be using like 1.25 kilohertz only for this guy. A lot lesser subcarrier spacing we use. The meaning is subcarrier spacing for the other channels and this channel is not same, is what I'm telling you. It's different. How many number of samples you will generate is T number of samples, except your cyclic prefix part. This is cyclic prefix, which will get added. That's why we are minusing them first. Later it will get added, the cyclic prefix portion that you have to attach at the starting. First you generate the samples and then these parts will be added at the starting. That's why they're minusing. You can ignore that mathematics. But you generate T of them, T minus your cyclic prefix part. You ignore and generate that money. Okay. So after you complete this time domain sample generation, you transmit that in the air by multiplexing it with the carrier wave. Now, what is the logic behind this special preamble? How it works out? Preamble contains the generated samples plus added cyclic prefix portion at the starting. But once you allow to transmit it on some particular band on PRACH resources, you would transmit it, obviously. Those samples you will transmit it by using the PRACH resources. But the idea is there will always be, when you are transmitting the preamble, which is containing the cyclic prefix portion and the actual sequence converted into samples, to transmit the entire thing, there would be definitely there is some amount of gap in the before the next scheduled transmission start, maybe for other channel or something, but you would be given some amount of gap. Why are we giving this amount of gap? What is the gap needed for there? Because when mobile is transmitting the preamble for the first time on PRAH, it did not apply the timing advance or timing adjustment already. Now you know that mobile is whatever it thought that is the starting of the slot, that is where mobile transmitting its its generated carrier wave. You know that once it is received at the G node B, G node B knows that it will be delayed. Now you should not exactly make the signal fit into the slot size. You have to prepare such kind, you have to ask the mobile equipment to prepare such kind of a signal that is having lesser size than your actual slot position or your resource position. That much amount of time that you are giving as the gap, you're giving it for traveling opportunity, even if it is delayed and traveled. So this is kind of this is the transmission which mobile is doing at the starting of the slot position. This is a reception which is happening on the G node B, but it is not peeping in into the next resource position, because we have given that much amount of gap where there is nothing transmitted from the mobile. So they are allowing that amount of gap. Can anyone tell me what is the size of that gap? Anyone? What should be the size of the gap? Okay. The size of the gap dependent on the cell size. If the cell is really big, there is might be a mobile who is at the edge of the cell. He wanted to transmit its preamble signal to reach at G node B. Now the gap should be sufficient enough to make the mobile equipment send this signal cleanly to G node B without making this pop into the next guy's resource. If, for example, if this resource block number 5 is allocated for the PRACH operation in this particular slot, in the next slot it is getting allocated to somebody else who is nearby. If this guy is going to use that resource block, you have to make this random access signal not popping into the next guy's slot position on the receiving side. So this the amount of gap should be fitting enough to give enough time to travel through the path, through your cell. If your cell size is increasing, you must have more gap if the cell size is increasing, because you are giving a transmission opportunity for the mobile to transmit this preamble from a faraway distance. So the gap should be increasing. The gap should be more. But what is the purpose of the operation we are doing? Uplink synchronization, timing adjustment. Right now, mobile transmitting the preamble without timing adjustment. So definitely delay is expected. So you have to counter that. How? By giving the gap. So, but after receiving the preamble, GeoDB kind of can come to a conclusion. Okay, from this mobile, I have received so and so preamble, fine, but it is delayed by this much amount of time. I know that, because on the receiving side, you are estimating when you started receiving, when up till what time you have received it. So you know now what is the delay from this particular subscriber. Based on it only, you provide the timing adjustment to the mobile in the next message. So these gaps are going to be different for different uh, configurations, different cell sizes. So based on different cell sizes that they wanted to configure, they have decided different formats. Format 0123 can be used for this LRA size 839 when the delta FRA is operating on 1.25 and 5 kilohertz. The subcarrier spacing for the your random access PRACH subcarriers. Either it could be 1.25 kilohertz or 5 kilohertz, not 15 or 30. The one that you are using it for normal things. You are using much lesser subcarrier spacing here. Now, how many samples you will generate is very high, 24,576 samples in one case. And to send these many number of samples, because we know the sample rate, you have to generate these many number of samples. So you definitely know to send these samples plus the cyclic prefix part that you are adding to it at the starting, how much amount of total space you need to reserve. Do you require to reserve one slot or two slots or three slots? How many slots you require to reserve? The corresponding reservation would be done to send these many number of samples. But why are we having the different sample rates here with the different formats? So the idea is to let the mobile equipment transmit a signal from the uh, from a higher distance. We are basically going to increase these sample rates. If the more number of samples are there, the carrier wave would be for more time. If the carrier wave is for more time, it is considered as wavelength. So it can travel from higher distances. So depending on the cell sizes, so they will configure this. There is too much complex logic located inside it. We are not going into the deeper details of that. But the size of this would be varying on the basis of the size of the cell as well. To somehow make the mobile equipment be able to transmit these PRAT samples from a higher distant position also. But for some technical reasons, they have decided different formats. Like totally how many number of samples you have to generate, how much cyclic prefix samples that you have to add. Now, what is the point is, for example, if it is 24,576, whatever these 839 symbols you have decided to send, each of those 839 symbols would be placed at 839 different delta FRA, different subcarrier spacing, and each symbol would be converted into these many samples in the time domain by performing the IDFT operation. And for that, you add these many time domain samples at the starting once again, because that is the cyclic prefix part to avoid ISI, intersymbol interference, coming in from the delayed signals from the previous symbol position. We use 0, 1, 2, 3 for bigger cell sizes. We use A1, A2, A3, B1, B2, B3, B4, C0, C2, typically for smaller cell sizes. We use this. Of course, again we have in 1151 we use it for bigger cell sizes in this 1151 case. But various network conditions, various cell sizes, depending on the network geographical scenarios, operators will decide which preamble format is suitable for the cell that they are bringing up in the network. And to carry these time domain converted symbols uh, onto the air. So this is the kind of design like uh, for some format 0, you send the sequence and cyclic prefix and you have a gap. But format 1, you have sequence repeated 2 times. Maybe the format 2, sequence repeated 4 times. Maybe in high speed conditions. So you want to make the mobile equipment send the signal for accuracy, because your high speed thing, you may be missing some samples as that samples are tightly distanced. You'll be losing some of the symbols because of the Doppler effect. So you need to make it transmit once again, once again, once again. So if you receive the sample in here, you receive the sample in this particular part, the same sample that you missed here because of the Doppler effect. So different formats for different um, geographical conditions. I did not draw all the A1, A2 smaller things, but they would fit in only this much size in a slot. But operator's duty is to decide it and uh, finalize which format, but it would be conveyed to the mobile equipment. The table is very big, which I cannot actually show it to you in the PPT. If I have to show this to you from the spec, so this is the table. So it kind of this PRACH configuration index value would be provided to the mobile in as part of system information. For example, if the value provided is 15, the meaning is the preamble format the mobile should use is 0, and the subframe number in which it can transmit the preamble, if it is 14, if it's going to be 7. In this subframe number 7, you are allowed to transmit the preamble. And from which starting symbol you can transmit the preamble and other lot of other technical details interlinked with it. So this preamble PRACH configuration index value ranges from 0 to 255, I guess. Yeah, up to 255. So where each number, when it is changing, it will give you the preamble format that you have to transmit in that cell, and that too in which subframe numbers you are allowed to transmit your preamble. Sometimes you have more opportunity to transmit the PRACH preamble in these kind of cases, where in each and every subframe you are allowed to transmit the PRACH in some frequency and time domain location. Some cases you will have less opportunity. Some cases only one time in every radio frame, one time only you can transmit. Next time you have to again wait for the next radio frame to transmit, because once this subframe 4 goes by, again only it is allowed in the subframe 4 and the next radio frame. Radio frame changes every 10 milliseconds once. So a number of times you would be given is less. Number of opportunities you would be given is less. If more subscribers are there, operator would configure higher opportunities for transmitting preambles. If the population is high in that particular cell, if the population is low, you would be configuring the preamble transmission opportunities less number of times, because this kind of waste the resources. Okay, let us go back. So you transmit that special preamble Jadavcho sequence. So we are damn sure that if it is received by G B can cleanly receive it without having any issues, much of the problem. But there is a probability of collision also. If multiple guys transmit the same preamble at the same time, G will detect only as one preamble instead of two. If two guys start transmit different preambles, G can detect them easily, separately, that there are two different preambles in it. Okay, now after this, mobile equipment will have to calculate ARIA RNTA based on the position where it has transmitted the PRACH. Why? Because if GNODB is allocating any resource, mobile equipment, GNODB is going to respond back to this preamble by sending something called as a random access response. That random access response is going to come to you where it is going to come to you, this RAR, by reserving some resources on PDSCH. But to do the reservation on the PDSCH, scheduling details must come on the PDCCH in the form of DCI. DCI's CRI must be scrambled with your RNTI. But you don't have RNTI, you are just coming up in the cell. You don't have RNTI available. So there, how can network tell you which resources are allocated for your downlink operation? When it is sending the RAR, where exactly it is sending the RAR? How can network can convey that information to you? Of course, you might listen to PDCCH, but when you download which information you look for, where you look for your information, you don't know your RNTI. So for that purpose, they have implemented the special concept called as ARIA RNTI, random access RNTI. How to calculate the RNTI without allocating? It is calculated on the basis of exactly on which location your preamble is transmitted. That location based details, time domain and frequency domain location based details would be taken, and from that RERNT would be calculated by the mobile. and which of course can be calculated by Gnode B as well. So how it is calculated is this with this formula. RARNT is equal to 1 plus SID 14 into TAD 14 into 80 FID 14 into 80 into 8 into uplink carrier ID. This is the formula that is known to every 5G mobile phone. So you substitute the things. For example, which OFDM symbol you have used to transmit your PRAH number from 0 to 14, where you started. That SID will go here. Now, which slot, you have transmitted in slot number from 0 to 18 in your radio frame, because maximum number of slots can be up to 80 in the higher bands. Which slot you have used? For example, if you take 30 kilohertz subcarrier spacing, number of slots only 20. Number of slots are only 20, not 80. 40, not 20, 40, 0 to 40 that time. So that value goes in here, TAD. Now, which frequency resource you have used? There can be multiple frequency resources reserved for PRAH, out of which you are going to use one. Maximum there can be eight resources that can be reserved for for PRAH operation in the frequency domain. Number of resource blocks that can be reserved. But which one you are using out of them to transmit your PRAH? That will go in as the FID. Now, uplink carrier ID would be applicable only in case of, SUL, supplementary uplink. It should be used as 1, otherwise it should be used as 0. But we'll ignore that part, uplink carrier ID. You can consider it as 0 when you are using normal uplink scenarios. So this whole term will become 0. Only this will give you what is your RARNTA. Now the RARNTA is calculated by the mobile because it knows exactly where it is transmitting. And the Gnode B who receives it also can calculate this RARNTA. Reason is, whenever mobile transmits, Gnode B receives at that time. So Gnode B knows where exactly it has received this preamble, in which slot, which symbol position it has received, and starting from which symbol position in which slot, and all the other details like which frequency resource it has received. So Gnode B also calculates. And this RARNTA matches both sides. Whatever RARNTA UE calculated, the same thing calculated by Gnode B. Because transmitted one is equal to received one. Transmitted numbers are equal to received numbers. That means this is the intelligent mechanism of allocating a RNTA to the mobile without allocating one. Without Gnode B have to tell him about one. So it's mobile calculated, Gnode B calculated. And Gnode B is going to use this RARNTA to further communicate with the mobile in the next step. Now, immediately what will happen? Physical layer, by analyzing this received preamble symbols, first it received preamble samples, some 27,000 samples, etc. it received, convert it into symbols, 839 symbols. From the received 839 symbols, the physical layer detect what preamble number we have received. And the physical layer convey that information to a MAC layer. Hey, so-and-so preamble number we have received from the mobile. I'm telling you. And the MAC layer immediately allocates radio resources required for the subscriber. It allocates 2 radio resources. It allocates downlink radio resources, uplink radio resources. Downlink resources are required to send the information that you are going to send in the downlink direction now. Send it back to the mobile. If you wanted to send anything to mobile, you need downlink resources. But mobile sent this preamble or started the random access procedure so that it would like to send, it can send this message 3. Actually, the message 3 is what is triggered this procedure altogether. So what does the Gnode B do immediately after getting this, after allocating the scheduling resources? It will ask physical layer to send 2 things. It will ask physical layer that, hey, you need to first send the DCI about downlink resources that we are allocating to the subscriber first. You convey DCI. If, and please distribute this DCI by using RARNTI, because mobile knows this RARNTI. So you please pack these DCI details on the PDCCH channel, and that PDCCH CRC, you scramble that PDCCH CRC with this RARNTI, with the mobile RARNTI, mobile specific RARNTI. You scramble it. You convey that to physical layer. Then also, GNodeB gives this uh, random access response that we have prepared to the mobile. But this random access response need to be carried on PDSCH, not on the PDCCH. So this should go on the PDCCH. This should go first on PDCCH, which will kind of tell the mobile equipment which PDCCH it have to look for. But by using this also would be sent on RARNTI. Then after that, this should go on PDSCH by using the corresponding resources reserved for the mobile. You send the random access response in which the GNodeB is packing the required details, wrap ID, whatever the preamble number we have received, the same number would be sent back to the mobile as a confirmation, kind of telling him that, hey, this is what you have sent me, right? Timing advance information, PUSCH scheduling information that mobile is requested for. All these details would be present in this random access response, plus temporary CRNTI. So network is allocating you one temporary CRNTI, telling the mobile that, hey, now for this operation, I know that you are using RARNTI, but next time onwards, we don't use RARNTI anymore. I'm upgrading you to temporary CRNTI. Of course, once you send your RRC connection request and I accept your connection, I'll upgrade you to the next level. I'll give you CRNTI. That is kind of the number that you are seeking actually. Cell radio network temporary identifier. So there are stages. But right now, the scheduling details should not be sent on temporary CRNTI. Reason is mobile don't know it's temporary CRNTI yet. It don't know that yet. Only the number that is known to the mobile is only RARNTI that it is calculated on the basis of where it has sent the preamble, in which slot, which position it has sent the preamble, on the basis of that. So, so what are we doing? First, the physical layer packs this DCI, sends the information to the mobile's physical layer, PDCCH, DCI by using RARNTI scrambling. Mobile is kind of waiting for that because it, from the moment it sent the preamble, it knew that it is waiting for it. The moment it receives, mobile would feel very happy. Okay, uh, GNodeB received my preamble. I think that's why it is replying back to me on my RARNTI. And now it will download the PDSCH that's going to arrive immediately in the resources that are scheduled, whatever that is suggested by the DCI, the frequency resource and time domain resource. You receive that, the random access response message that is arriving in PDSCH channel. Of course, you won't receive it as it is. It will be very heavily processed. Like you add the coding information, CRC, etc., etc., etc. All those things would be done, and then that arrives on PDSCH because mobile is already ready waiting as per the DCI communication earlier. It downloaded, but after downloading and decoding it, physical layer has got nothing to do with this RAR because this RAR is prepared by who? MAC layer. So physical layer kind of considers this RAR as MAC layer's information, and it simply need to extract it and remove all the CRIs and all the excessive stuff that is added, the coded bits and so on. It will remove everything, the scrambling process, it does the descrambling and so on, and it extracts the original random access response out of it, and it delivers that to MAC layer with all the details in it, containing the wrap ID, timing advance, PUSCH, scheduling information, and a temporary CRNTI that is provided to the mobile. Everything is sent to MAC layer. Now, MAC layer does what? It will, whatever the preamble number it has selected earlier, for example, if it has selected preamble number 37 earlier, it will check in this random access response, the wrap ID received is 37 or not. It will kind of verify as a step. If it is 37 indeed, then it will go to the next step. It will understand this timing advance and say, oh, I have to transmit the data like 30 microseconds early this time. But if physical layer need to transmit 30 microseconds early, MAC need to prepare the transport block 30 microseconds early. That is why timing advance is important for the MAC layer, not for the physical layer only. Physical layer have to apply the timing advance, but MAC also need to prepare the data that 30 microseconds advanced, because physical layer is sending the data that is prepared by the MAC layer. Physical can't send 30 microseconds advanced if MAC exactly gives a perfect time. You can't do that. You have to expect MAC also to send 30 microseconds earlier. So that's why this timing advance information is going to MAC. Actually, this entire RAR is going to the MAC layer. So MAC layer says, okay, we got resources, we got timing adjustment. So now I know where exactly to transmit, how early I need to transmit in uplink, etc. Mobile is prepared for the next step. That is, whatever the notification came from the higher layer from RLC that the data is there waiting in its buffer, you kind of ask, go and talk to the higher layer and take that data. Then message 3 that is waiting. Already message 1 and message 2 are completed, preamble and random access response. You take that message 3 and you start transmitting that message 3. Tell the physical layer that, hey, I'm giving you this message 3 little advanced, 30 microseconds advanced as per the TA. You also have to transmit it on the PUSH by converting, by processing this message 3 according to PUSH channel processing like CRC, coded bits, etc. And is transmitted this much early, timing advance suggested early. You are telling it to physical layer, and the physical layer does all the duty and transmits that PUSH message 3 on the PUSH channel. It adds the CRC coding information, scrambling, everything, date matching, all those duties it will perform. Then the, GNODB's physical layer, after receiving this message 3, it would kind of extract it and send it to MAC, because it is not physical layers. It is not control information going from physical to physical. It is carrying higher layer information. So simply physical layer would dispatch it to the MAC. Actually, MAC also knows that this message 3 is higher layer data, because on the sending side, it is coming from higher layer, RLC or RRC, for example. Now this message 3, MAC layer cannot respond back to this message 3. So MAC layer also send it to higher layer. Hey, you have received a reply, you have received a message, maybe RRC connection request, I think. So MAC layer sends it to RLC, RLC sends it to higher layer. So finally it reaches RRC. RRC receives this, understands that it is a request from the mobile requesting for radio connection. It kind of generates a reply for it. Once the reply comes back in the higher from the higher layer, MAC prepares its next message. Because it has received message 3, now there is a step 4 that is pending, where we are kind of validating whether this mobile will have to wait for acknowledgement to identify whether this procedure is successful or not. So what does the MAC layer do? Tag this message 3 reply and need to send it to the downlink to the mobile. Now it does the resource scheduling. Again, downlink resource scheduling it would do, GNODB. Resources need to be reserved on PDSCH to send this message 3 reply. But at the time of sending this message 3 reply, it also packs the CRI for which the mobile equipment is waiting, contention resolution identity. So first it will pack DCI and send to the physical layer, which conveys the scheduled resource related details. And then we have the message tree reply that is come from the higher layer plus the CRI. The CRI is nothing but the message tree that is received itself. Would be packed along with the message reply. Now this whole thing is considered as your payload. This message reply plus the CRI all together, it is considered as your payload. That is what MAC layer is sending to physical. Physical will consider this whole thing as the transport block, and it will start processing CRC adding and all those things. GNODB's physical layer when it is sending in the downlink direction. But first it will have to dispatch this DCI to the mobile. DCI need to be dispatched by using RNTI, by scrambling the DCI CRC with the RNTI on the PDCCH resources, which mobile is listening to. So we send the DCI first on PDCCH resources by using temporary CRNTI scrambling. We won't use RNTI anymore. Why? Because mobile already got upgraded to temporary CRNTI. You don't need to kind of use this RNTI anymore. You can stop using it. Because in the random access response, already this temporary CRNT is provided to the mobile. So RNT is used only for one step, single step. That is during your preamble sending and receiving RAR. Preamble sending, it is calculated. While receiving the RAR, on which PDCH resources your RAR is coming, to know that you listen to PDCCH by using your RNTI. So you kind of try to see where your DCIs are scrambled with your RNTI number. You look for that. Okay. So then what do you do? So after receiving this DCI, you wait for whatever the suggested whatever the resource that is suggested by DCI on the PDSCH, you download that PDSCH. Mobile would download it. So in that, the payload that is present is message tree reply and CRI, contention resolution identity, which is in the physical layer format, CRC, coding bits, etc., etc., etc. So after the physical layer processing all that, the actual information would be extracted and it is sent to MAC layer. MAC layer receives the message reply and the CRI. Now it will do some kind of a validation. U is MAC layer. What validation it performs? It checks whatever the message tree that I have transmitted by using the resources allocated for me, is it equal to the CRI that I am receiving? They must be equal. Only if that is equal, I will consider this random access procedure as successful and send this received message tree reply to the higher layer. If it is yes, if the message tree that you have transmitted matching with the CRI that you have received. If not, if if the answer for that decision box is a no, then mobile will have to consider this entire random access procedure it performed is failed, and it will have to restart the random access procedure once again, starting from the scratch. Select a new preamble number and transmit that preamble and everything. So it's some kind of a collision occurred somewhere. That is the only case when this occurs. This will be a failure. Otherwise, it will match if no collision occurred. So when this collision occurs, what are the collision scenarios? How this whole operation works out? For that, we have to see negative cases in this. To understand the negative cases, we have to take multiple mobile phones into the play. Of course, we see positive cases, we need negative cases and mixed, uh, related to multiple subscribers. So here now we have involved two UEs, one GNODB. So two UEs are kind of sending preamble like exactly at the same time. So their message trees were reported from higher layer. Both the MAC layers decided to start random access procedure so that they can dispatch these respective message trees. And one message tree, we have called it as message tree 1 belongs to UE1, message tree 2 which belongs to UE2. Just for easily identifying them, that's all. There is no message tree 1 and message tree 2 in the specifications. I have named them just to segregate in this example, only for this example purpose. So they started random access procedure, both of them. Both the MAC layers picked up the preamble, and luckily here they picked up different preamble. UE1 picked up preamble number 15, UE2 picked up preamble number 23, because they're randomly picking it up. And when we are picking up two different preambles, they won't be collided. GNodeB would be able to definitely be able to receive both of them cleanly, because from the mixed thing it can extract what are present inside. That's the idea here. But mobile equipment to first convert that preamble for, so both of them will generate the 839 symbols if you take 839 is the configured format, and then that will be cyclic rotated, cyclic shifted. The cyclic shift will be different for UE1, different for UE2, in order to make them unique, orthogonal, in order to make those symbols orthogonal. So that total preamble sequence would be generated. It will be converted into time domain samples. Some 27,000 time domain samples it would be converted into. And that samples would be transmitted on the given physical resource. It would be transmitted. But the situation we are considering is UE1 is using very less power to transmit the preamble. UE2 is using adequate amount of power to transmit the preamble. Now, why UE1 is using the less power? Why UE2 is using adequate amount of power? Why is that? What happens when you use less power? The signal may not be able to travel and reach the destination. It might die in the middle if we use very less power. But why mobile one is using less power? Why its signal is not reaching eNodeB or gNodeB in this case? Because network suggests the mobile equipment with which power it'll have to start transmitting the preamble. It'll kind of suggest it. Why? Because I told you in uplink, network does something called as power control. It won't allow the mobiles to use the power of the one that they want, or any power that they wish. You'll have to very tightly control the uplink power. In the system information block that the mobiles received, mobile was advised about what power they have to start with when they are started transmitting the preambles. Also, network would advise that, hey, if you guys started transmitting the preamble with less power, maybe you may be there at the cell edge. Your preamble may not reach me. If your preamble did not reach me, I'll not respond back to you. So you won't receive the RAR. If you don't receive the RAR, after waiting for the RAR for some time, if not received, you consider that your preamble is missing. Now, next time, I'm allowing you to increase the power by some X units of power. So you increase the power a little bit more and try again. Try to transmit the preamble one more time. Now, the situation here is UE1 may be far away and it just now started with the random access procedure. So definitely it would have used the starting power that is suggested by the gNodeB, and that is not adequate enough to make the signal reach the gNodeB. So that it's failed. It never reached. But UE2 kind of lucky, it is maybe nearby, even though even we consider UE2 is also just now started. But it is near to the cell center, and with the initial power itself, the signal reached the gNodeB. But immediately what happens, both these mobiles have calculated their area RNTIs based on where they are transmitting this preamble, which position they have transmitted this preamble. They calculated area RNTI. Because we are considering both the mobiles are transmitting ARIA and preamble at the same time by using same resource. That is the situation we are considering here. So the ARIA RNTA is X because both of them are transmitting it in the same resource, same PRACH resource. So their SID, TID, FID, all the values are same. So their ARIA RNTA is also same. But the problem is GNode B has received only one preamble, that is preamble number 23. And it thinks that preamble number 23 is arrived from the mobile who must be identified with ARIA RNTA X. That X could be anything depending on where they have transmitted their preamble. In that equation I have showed you, it calculated on that equation. But only one preamble reached GNode B as the power because of the power deficiency from UE1. Now GNode B's physical layer sends that preamble number to MAC. MAC will only prepare the resource scheduling for one subscriber out of these two guys. But convey that information with the DCI first and RAR. Only one RAR we are packing. One random access response containing the resource details only for one guy with only one temporary CRNTI. Other details I have kind of ignored here. It will be repetitive. Timing advance, PUSCH resources, everything will be there. But I just decided to not to add everything every time. And this RAR also contains the preamble ID, the 23 preamble number also present in it, in the RAR. But this DCI would be sent on PDCCH by using RARNTI, not to X. By using whatever the X is, I did not replace the number. It should be X there. On that X, it would be advertised. But the problem is, when it is advertised with X, you even thought that that is his RAR, that is his resources. You even also thinks that that is his resources. Because uplink signal did not reach me doesn't mean downlink signal won't reach. Downlink signal is transmitted by GNode B with high power, even it can reach to the cell edge. But uplink power is transmitted by the mobile. It is using less power at the starting. So downlink signal always reachable. So both the mobiles will think that, hey, that whatever the RAR that is coming to them on the PDSCH channel is for them. Both of them will think that. And what do? They will decode that RAR immediately. Both of them would decode it. And whatever the RARs that are present inside, they will extract after processing. They will send it to their respective MAC layers. But when the MAC layers will come to a realization, this UE2 will open this RAR and see its preamble number 23 present in it. And it will continue to do the rest of the operation to complete its process. Because inside the RAR, the preamble number you have sent is also packed in the RAR. So it found out whatever the number it has sent, it found out in that as one of the fields in the RAR. So UE2 thought that this RAR is in fact for itself. But UE1, what does it do? It finds out that once it decodes the RAR1, it finds out that, hey, the RAP ID that I have sent is 15. The RAP ID that is present in this RAR that I have received is 23. That means this RAR is for somebody else. I thought that it is for me because the scheduling happened on my RNTI, my ARIA RNTI. Maybe when I have sent the preamble, somebody else also might send the preamble at the same time, but my preamble never reached. That's why GNode B did not detect it. The other preamble, which is 23, definitely would have reached. That's why GNode B is responding back to that guy, 23 guy, and sending the RAR. But I have received it as I am listening on ARIA RNTI on this PDCCH channel. So I thought that it is for me. But when I opened it, I realized it is not for me. So what does UE1 do? UE1 will have to redo the random access procedure starting from the step 1, but next time it will have to enhance the power. You have to increase the power. Whatever the power you have used earlier, you will be increasing it. So this is the power adjustments or uplink power control mechanism related to this particular channel. UE2 will continue and complete its procedure, rest of the steps. So it sends the message 3, it receives the reply, and it will conclude that the message 3 it has sent is equal to CRI with matched, and it kind of says that the random access procedure is successful, and it sends this message 3 to the higher layer. So it kind of completed this task. It never need to wait. So for one guy, it is a negative scenario. For another guy, it is a positive scenario for UE2. We'll consider one more case. They picked up the preambles. Both the preambles reached Gnode B. Because UE1, this time we are considering that both of them are in the perfect distance to send their preambles properly without less power. They have used adequate power, or they are very nearby when they started this activity. So with the initial power itself, the preambles reached. Gnode B, because these are Jadov-Cho sequences or Jadov-Cho symbols, their specialty is they are orthogonal. You can easily detect them even if they are received combinedly. So Gnode B from the combined signature, it will be able to separate out these two signatures and identify that, oh, on this particular position with RARNTA number X, I have received two preambles, preamble number 53 and preamble number 15 and 23. I have received. Gnode B detected them. This is not a collision scenario. Even though the preambles are colliding, because of their orthogonal property, Gnode B would be able to separate them. This is not a collision situation. Don't think that it's a collision situation. Now, what does Gnode B do? It sends these two RAP IDs to MAC layer. We have received two random access preambles from two different mobiles. MAC will prepare radio resources for two guys. Okay, it will pack the DCI information. Two RARs it will pack. One RAR for one subscriber with two temporary CRNTIs. And first it will dispatch the DCI with the RARNTI X. Both of them will think that RARNTI is theirs. They will decode that, and they will immediately decode the PDSCH. But the PDSCH arriving with a couple of RARs instead of one RAR. And their corresponding physical layers, they will download both the RARs, dispatch it to MAC layer. Now MAC layer can easily detect in which RAR your RAP ID is present. So maybe, for example, in RAR 1, the RAP ID 15 is present. In RAR 2, RAP ID 23 is present. So UE1 and UE2, what do they do? UE1 will only consider its RAR, and the other RAR it will throw into dustbin. UE2 will consider only RAR 2, and RAR 1 it will throw into dustbin. But each RAR containing different uplink resources, different timing advance, calculated by the Gnode B for both these guys. Two resources prepared. So they will consider their RAR, the one that is associated with the RAP that they have sent, and they will proceed further and continue their operation till successful. So this is a successful scenario for both the guys. Both of them will receive the replies. Both of them will receive, their corresponding CRIs, and both of them will consider random access procedure as successful. Because there are two resources reserved to make the mobile equipment, mobile 1 send its message 3, it has got a separate resource, PUSCH resource. To make the mobile equipment 2 send its own message 3, it has got a separate resource. So there is no collision that is going to occur for PUSCH, because this guy would be using PUSCH PRB1, this guy would be using PUSCH PRB2, on which you send message 3. So these two messages would be sent on two different PRBs, two different resource blocks. So both of them would be cleanly received by Gnode B without any collision. So once both of them are received successfully, for both of them the replies will be prepared. Two CRIs would be coming in the downlink separately. So mobile 1 CRI matches with its message 3, mobile 2 CRI would match it with its message 3. So once they match, they'll consider that procedure as successful, proceed further. No worries. One more scenario. Again, they started. Again, we are taking, okay, take a look at it. Unluckily, both UE and UE2, UE1 and UE2 picked up the same preamble number when they are like, picking up a chit from 0 to 63. They picked up the same preamble number. So what do you do when you pick up the same preamble number? Unlucky, they don't know that this is happening with each other. They are not coordinating. They transmitted. But we are again transmitting situation we are considering. UE1 is using less power, UE2 is using more good power to reach this G-node B. G-node B, they calculated RA, RNTI, but G-node B received only one preamble, 15 anyway, and sent to Mac. Mac prepares the resources, and one RAR prepared, and both of them will download that RAR because that is arriving on their RA, RNTI number. But the biggest problem that happens here is when the information is sent to these corresponding MAC layers, both the MAC layers will see that inside the RAR, the preamble ID that is present is 15 only. UE2 sees that it is 15. UE1 sees that the preamble number is 15. It is my preamble number, whatever the preamble that I have transmitted. Actually, UE1's preamble never reached G-node B. He is not aware of that. It is completely getting thrown out of the situation by thinking that whatever the thing that is happening with UE2, it is thing that is for himself. Because the preamble ID matched. As unluckily, this UE1 and UE2 have used the same preamble at the same time. And that preamble number did not save. Earlier, at least the preamble number made the UE1 recognize this situation and stop the procedure and restart it once again. But this time, at least that's not happening. So what will happen now? Both of them will prepare the message 3, their own message 3 is transmit on the same PUSH resource. Only one resource prepared, not two resources. One resource on the PUSH. But luckily, what happens here in this case is UE1 would use same amount of power. It use the power for PUSH, the same amount of power it has used for transmitting PRACH signal. It will use the same power because it believes that its preamble procedure is successful. It is believing, so it thinks that the power is adequate enough to transmit even PUSH as well. Whatever power it is using for PRACH is directly applicable for PUSH as well. Next time when you are transmitting, so they will use their respective powers. But that is a lucky boon for us. Mobile 1, even though it is transmitting its own message 3 by using the same resources, it's kind of trying to create the conflict. But because it has used the less power, the same power it has used for PRACH, with which the signal never reached G-node B, this time also it won't reach. It will die in the middle. Only UE2's message 2, message 3 will reach G-node B because it is using same power that it has used for the preamble. So G-node B would be able to extract message 3 2 and it sends it to the higher layers. Once the reply is received, it will prepare the reply along with the CRI. CRI is matching with this message 3 and it will reserve only one DCI, not two DCIs, only one DCI and dispatch the information on temporary CRNTI. But the problem is this mobile is still under the illusion that the G-node B is dealing with him when this temporary CRNTA number is advertised with the DCI. on PDCCH, the temporary CRNT that it has received earlier. UE1 thinks that, hey, it is mine. So they whatever the data that is coming in is my data. So I'm getting the reply. UE1 thinks. UE2 also thinks that. UE2 also believes that. So both of them will download the upcoming PDSCH. Both of them would download it. So they would receive necessary to reply along with the CRI. So that their physical layers process the data, remove all the CRCs, etc., send it to MAC layer. But now the MAC layer's duty is to do the validation. Now UE2 will match the CRI that is received is matching with the message tree that it is transmitted or not. And it is in fact true. It is a yes. It will conclude that its random access procedure is successful, and it sends this message tree to reply whatever we have received for message tree. It sends it to the higher layer. So it will consider its random access procedure as good, successful operation. But now UE1 will come to the hard reality after receiving this CRI. The CRI is the user 2 CRI actually. User 2's message 3. Only operation that was successful is UE2's. But because these guys picked up the same preamble, this whole confusion is taking place. But now UE will come to the realization when it opens this CRI, it never matches with the message tree that it has transmitted because it's UE1's message tree, UE2's message tree will be different, at least by 1 or 2 bits. So when it does the comparison of the message tree, the moment it will compare, it says that no, it is not my message tree. The CRI that I have received is not matching with my message tree that I have transmitted. That means all along what I thought is my procedure that is becoming successful indeed is not. So this random access procedure completely failed. I think my preamble never reached Gnode B. My PUSH PRB that I have transmitted by using the resources that I thought is allocated to me also not reached at Gnode B. Somebody else's preamble reached the same preamble they have picked up as mine, and that somebody else's message tree reached, not mine. So this guy would have to go for performing random access procedure once again by starting from the scratch. But this time it will increment the power. Now, one more last lucky case or unlucky case. 2 is decided, they decided to transmit same preamble number. They're randomly picking it up, but unlucky for them, they picked up the same preamble number. But more unlucky, at least in the earlier case that happened, UE1 signal never reached Gnode B. But in this case is both the preambles reached Gnode B. Because they have used adequate power. Both of them are in the nearby distance. Actually, what happens? They'll get collided, combined, and Gnode thinks that it is a single signal that is being received, which is preamble number 15. That's it. Only one thing is received. Because Gnode can never detect that there are two different preambles in it with 15 and 15. That you cannot segregate. Orthogonality won't be there between the same preamble number. Orthogonality would be there only if there are two different numbers. You can segregate them. Gnode can separate them and identify. It thought that it has received a single preamble, which is 15. So Gnode prepares the resources only for one guy and schedules and sends. And now both UEs will think that resource is for them because it's matching with their ARIA RNTI. So they will download the RAR that is arriving on the PDSCH channel. They will get this temporary CRNTA number. They will also get to know their preamble ID. Their preamble ID matches as well, 15. So both of them will think that the resources are for them. Both of them, UE1 and as well as UE2. Nobody's fault here now. Both of them will transmit their respective message trees by applying the respective timing advance on the PUSCH resources, they will transmit. But unlucky, as both of them are using adequate amount of power for PUSCH, they they apply the same amount of power they have applied for PRACH. So obviously, PUSCH signal is definitely be reaching G node B, no question about it. Now, if they are transmitting the data, their respective data by using the same resource, two signals which are getting transmitted on the same frequency resource, same scrambling sequence, everything, because to generate the scrambling sequence for PUSCH, both of them will use temporary CRNT as the one of the element inside the scrambling sequence generation. So both their scrambling sequences are also same to generate this data, but data are different. But when they travel in the air, they get collided. Now, G-Node B will never be able to segregate them on the receiving side. So, G-Node B's physical layer would detect that the data is corrupted. The CRCs will corrupt because it's a mixed information you are receiving, mixture from two different mobiles who are using the same resource, same PUSCH resource to transmit two different messages. CRCs will collide, messages will collide, transport blocks are colliding, or basically your signals are colliding, which will collide the samples and it will corrupt everything. First guy's data would be corrupted, second guy's data is corrupted. Now, once corrupted, G-Node B identifies that these are all corrupted, these messages are corrupted. What does the G-Node B do is do nothing, actually speaking. It kind of says, okay, let me wait. I don't reply back to anybody because none of the messages are received cleanly. How can you send it to higher layer? In order to send it to higher layer, the message must be clear, without any errors. But both the messages, by colliding with each other, corrupted each other. So you can't talk to higher layers. You can't respond back to anybody. They kind of have to wait for some time, called as a CRI timeout, contention resolution identity timeout. The timer is set during system information procedure. So obviously, both UEs will wait for that CRI timeout, the message for the CRI. Let us suppose that they have set it, the value that is set it to is, 15 slots, let us assume. So they wait for 15 slots amount of time to receive the reply that they are supposed to receive, message 3 to message 3 reply along with the CRI. They'll wait and wait and wait. Once timeout occurred, but G-Node B is not talking to these two guys anymore. His guy kind of ignored them. They will, both of them will conclude that their random access procedure is failed after the timeout. And what do? After they detected that timeout, they kind of will go back and start the random access procedure once again. But the idea of the random access procedure is when they restart the random access procedure, again, there is no possibility for collision because they will pick up fresh preamble numbers randomly, and there is no possibility or very least amount of possibility that they will pick up the same random access preamble once again, second time also, because they are picking up chit from the box randomly. Next time UE1 might pick up 31, UE2 might pick up 25, two different numbers. When they transmit two different numbers, G-Node B would be able to successfully receive them because there is orthogonality between them. It is easily, it can detect 25 and 31 have been sent, and it can allocate the resources for two guys separately, two PUSCH resource blocks to be sent, to be sending two different message trees. So no collision. Collision will be avoided next time. Is this clear? Understood, everyone?
Yes, sir.
Now, we have to stop here for today. What is left out in uplink is what are the remaining uplink channels, PUSCH, all those things we haven't introduced, but it'll not take much time. Tomorrow we'll try to cover all the channels in uplink in the first 1 hour. So with that, our physical layer would be completed. Maximum we'll see how much time we can cover it up. Major procedures are done. And in our tomorrow's class, we start with the MAC protocol layer. Okay. And this random access procedure is not yet completed. This will continue in the MAC layer and a lot more to study related to this random access procedure, in which scenarios it would be used and so on. A very complex and a lengthy one. In Mac also we heat it up because Mac is directly involved in this operation. If you don't have any questions, let us break. Let's take a break here and come back and continue.